Welcome to a deep dive into the mind of a theoretical titan. This slide serves as the title introduction for a presentation dedicated to Lev Landau, aptly hailed here as the architect of quantum coherence. Set against a chalkboard background scrawled with complex mathematical equations, the overview promises to unpack three core pillars: his extraordinary life, his groundbreaking scientific achievements, and his monumental pedagogical legacy. It frames a comprehensive journey through the profound, enduring footprint this eccentric Nobel laureate left on the quantum world. We trace the turbulent trajectory of Lev Landau's life across a timeline styled as a dramatic, fluctuating graph. It begins with The Ascent, 1908 to 1929, highlighting his early brilliance in Baku and defining collaboration with Niels Bohr. Next comes The Abyss, 1938 to 1939, charting a sharp plunge into Stalinist imprisonment, followed by a triumphant arch into the Golden Era, 1941 to 1961, marked by prolific discoveries and his famous course of theoretical physics. A tragic bifurcation occurs on January 7, 1962, with a near-fatal car crash. The timeline splits into survival, achieved via historic global medical efforts alongside his 1962 Nobel Prize, and a final, somber eclipse representing the permanent loss of his scientific intellect until his death in 1968. Witness the shaping of a prodigy through a map of geographic and intellectual evolution. The narrative begins in Baku, 1908 to 1924, where the son of an engineer and a physician mastered differential and integral calculus by early adolescence. Next, the journey ascends to Leningrad, 1924 to 1927, where he graduated from university at just 19 while publishing his initial papers on quantum mechanics. Finally, the path crosses borders to Copenhagen, 1929 to 1931. Here, collaborating with Niels Bohr at the Institute for Theoretical Physics, he immersed himself in an environment of intense debate and collective brilliance, an experience that deeply forged his future pedagogical style and cemented his status as a foundational modern physicist. Step into the vast intellectual empire of Lev Landau, categorized here as a taxonomy of discovery. A poignant quote by physicist A.I. Akizer sets the stage, comparing Landau's breakthroughs to rare, precious stones forming a crown over his head. The slide organizes these gems into three major pillars of physics. Under condensed matter, we see his theories on superfluidity, Ginzburg-Landau superconductivity, and Fermi liquids. The plasma and electrodynamics column highlights Landau damping and the Landau pole. Finally, quantum and particle physics captures his independent co-discovery of the density matrix, the two-component neutrino theory, and Landau levels in diamagnetism, all accompanied by illustrative chalkboard diagrams of his foundational work. Explore the groundbreaking science that earned Lev Landau his Nobel Prize, presented here as the states of matter matrix. The slide provides a stark visual contrast between a normal fluid, characterized by friction, measurable viscosity, and thermal resistance, and superfluid helium-2 at temperatures below 2.17 Kelvin. Helium-2 exhibits zero internal friction, quantum coherence at a macroscopic scale, and infinite thermal conductivity, depicted as a fluid defying gravity to creep up and out of its container. At the bottom, the Landau mechanism explains his mathematical synthesis of quantum theory and fluid dynamics, highlighting his revolutionary introduction of quasiparticles, specifically phonons and rotons, to represent sound vibrations and vortexes within the fluid. Delve into The Geopolitical Crucible, Science Under Stalin, a sobering look at the perilous intersection of totalitarian politics and scientific genius. The narrative opens with The NKVD Arrest, 1938, detailing Lev Landau's year-long imprisonment in Moscow's infamous Lubyanka prison during Stalin's Great Purge, accompanied by a detailed floor plan of cell block number 5. Next, The Ultimatum highlights the immense courage of experimental physicist Pyotr Kapitsa, who wrote directly to Stalin demanding Landau's immediate release, boldly stating that science cannot be built on fear. The final chapter, State Service, reveals the stark compromise of his post-release years, leading calculations for the first Soviet thermonuclear bomb, earning Stalin prizes despite his enduring political skepticism. Step up to The Gate, a visual funnel illustrating Lev Landau's notoriously grueling theoretical minimum exam. The journey begins at the wide top with the comprehensive requirement, demanding total mastery over all branches of theoretical physics alongside complex mathematical analysis. Next, candidates are squeezed through the 9 brutal exams. 8 distinct physics disciplines and 1 in mathematics, administered individually by Landau on a blackboard with no notes allowed, prioritizing pure physical intuition over rote memorization. At the narrowest point sits the elite, revealing that only 43 candidates successfully passed between 1934 and 1961. Surviving this crucible transformed students into proper physicists, granting them coveted entry into Landau's legendary research group and seminar. Enter the crucible, the Landau seminar, mapped out as a dynamic, interconnected network diagram showing how knowledge circulated around Landau. As the knowledge ingestion engine, Landau rarely read scientific literature himself, relying on the seminar to stay updated. In the presentation, students were assigned recent global papers from journals like Physical Review, ZHETF, and Nature to study independently and present. The defense phase subjected these speakers to brutal, insightful scrutiny from Landau and peers, demanding complete mathematical proofs and absolute clarity. Finally, the penalty hung over every participant. Failing to adequately prepare or answer detailed questions repeatedly resulted in immediate exclusion from the seminar, keeping this intellectual ecosystem operating at peak performance. Behold the blueprint, the course of theoretical physics, a structured overview of the legendary 10-volume textbook series co-authored by Lev Landau. Displayed as a grid of chalkboards, each box details a specific volume alongside its foundational mathematical equation: 1. Mechanics, 2. The classical theory of fields, 3. Quantum mechanics, non-relativistic, 4. Quantum electrodynamics, 5. Statistical physics Part 1, 6. Fluid mechanics, 7. Theory of elasticity, 8. Electrodynamics of continuous media, 9. Statistical Physics Part 2 and 10. Physical Kinetics. The narrative at the bottom notes the epic timeline of this project, initiated in the 1930s in Kharkov and completed in 1979, earning the Lenin Prize in 1962 and selling over 1 million volumes globally by 2005. Examine the authorship paradox, the mind and the pen, which unpacks the legendary collaboration behind the course of theoretical physics. Introduced by the famous physics community witticism, not a word of Landau and not a thought of Lifshitz, the slide contrasts the two creators. Lev Landau, the conceptual architect, composed early volumes entirely in his head during his 1938 to 1939 NKVD imprisonment, utterly despising the tedious process of writing. Yevgeny Lifshitz, the mathematical scribe, was one of the first to pass the theoretical minimum. He executed nearly all the actual writing, translating Landau's physical intuition into exact pedagogical prose while contributing deeply to the course's mathematical rigor as a brilliant physicist in his own right. We look out across a polarized Cold War landscape to see how a singular intellect could bridge immense geopolitical chasms. Titled, Breaching the Iron Curtain, this slide charts the global reach of Lev Landau's genius through a network of prestigious accolades spanning from the Soviet Union to the West. Within the USSR, his status was cemented by his Academy membership, 3 state awards, and the 1962 Lenin Prize. Yet, his influence effortlessly transcended ideological borders, earning him coveted memberships in the Danish, Dutch, and American academies, alongside the British Royal Society, the Max Planck Medal, and the F. London Award. It stands as a powerful testament to science operating as a universal language. Step into the tragic final chapter of A Monumental Mind, The Eclipse, January 7, 1962. The narrative recounts the incident, a devastating car crash on an icy road to Dubna that fractured Lev Landau's body and cast him into a 2-month coma. Next, the global rescue highlights an unprecedented international mobilizations of the scientific community, bypassing Cold War barriers to rush top surgeons and medicine to Moscow. This effort culminated in the Hospital Nobel of December 1962, awarded directly to his bedside. Yet, the tragic aftermath lingers. Though his body survived 6 more years until his death in 1968, his brilliant scientific creativity was permanently dark, an intellectual eclipse from which he never truly returned. Step into the definitive blueprint of Lev Landau's intellectual empire, beautifully visualized here as the crown of gems. At the absolute base lies the mortar, the legendary, theoretical minimum, exam that forged a resilient pipeline of Soviet physicists. Resting upon it is the foundation stone, representing his monumental 10-volume course of theoretical physics. Swirling above are the scattered jewels, a dazzling collection of lifelong breakthroughs spanning the density matrix, Fermi liquids, and plasma damping. Finally, sitting proudly at the apex, shines the ultimate crown jewel, his Nobel Prize-winning work on superfluidity and phase transitions. Together, these architectural elements form the complete, enduring legacy of the titan who shaped modern quantum coherence. Step into the definitive blueprint of Lev Landau's intellectual empire, beautifully visualized here as the crown of gems. At the absolute base lies the mortar, the legendary, theoretical minimum exam that forged a resilient pipeline of Soviet physicists. Resting upon it is the foundation stone, representing his monumental 10-volume course of theoretical physics. Swirling above are the scattered jewels, a dazzling collection of lifelong breakthroughs spanning the density matrix, Fermi liquids, and plasma damping. Finally, sitting proudly at the apex, shines the ultimate crown jewel, his Nobel Prize-winning work on superfluidity and phase transitions. Together, these architectural elements form the complete, enduring legacy of the titan who shaped modern quantum coherence.